everyone, and welcome to our video on database design. Because if you want to make an amazing website, it's going to have an amazing database, it should have an amazing database design. Here on the right, we have a little website I made called Twiddle. It's from the Twiddle tutorials that you might have seen that I have on how to make a web application using the programming language Python and the framework or the module called Flask. If you haven't seen those tutorials, I quite like them. Check them out, they're good. So here is on the right a screenshot of what it looks like, and we're going to think about what the database would look like for the website. Because normally, before you start making the website, you have some vague idea about what the database might look like what needs to go in it. If we have a look at the different parts here, we can think about the different tables that we need. In other words, the different entities. Entities means things. So one of the types of thing that we're going to have to store is the users. You can see that I have two different users here, Bob and Violet. So the entity called user, that table has two rows in it, Bob and Violet. We're also going to need to store information about another type of thing. We can see that I have 3 posts. 1, 2, 3. So there's a post called I am Bob, a post called It is a nice day today, and a post called Hello everyone. So this is another type of thing that we need to store. There is one more type of thing that we need to store. In other words, another entity or another table. And that is down here, we have comments. We can see that there are 2 comments here. Hello Violet, you are great. And thanks Bob. So there are 2 comments, 2 rows in the comments table. So the first step when you're thinking about making a web app is to think about the type of tables that, one of the steps is to think about the type of tables that you need. And here we've just established that there are 3 different types of things we're going to store. So we're going to have 3 different tables. Table for users, table for posts, and a table for comments. We will focus on posts for now, just this one table. You can see there are 3 posts, and let's have a look what kind of information we need to store about a post. This here is a table. In fact, it is a screenshot of the exact database that powers this site that I made. You can see that the 3 posts are here. The table is called posts. That is the name of the table. I have 3 rows, and each row represents a post. If the table is called posts in the plural, each row represents 1 post, singular. So there's a post, there's a post, and there's a post. Each post has information about it. You can see that it has information. It's got the message is one piece of information, the username, the picture, how many likes the post has, and the date that the post was created. You can see that I made them all quite quickly. In other words, the table has 6 fields. A field is a piece of information for each row. So there are 3 rows, and each row has 6 fields worth of information. In this case, the fields are ID, message, username, the picture, likes, and the date created. So we've seen what a table looks like. When you are making a database or even planning a database, each of these fields will have a certain data type. So we can think about what data types we might use for this table. I'll show you some options as we go through this. The first option, what we have here as a whole number, is an integer. An integer is a whole number. So if it's a whole number, then that whole field, this whole column, will be a whole number. The next one here is text. So we can just say that's text. This one looks like it is also text. This one looks like it is also text. When I say text, I mean letters A to Z, symbols like slashes, full stops, numbers, characters in other languages. All of that is text. The next one here, well, this just looks like an integer again. It's a whole number. And this last one is a moment in time, the date that it's created. So we will call it a date time. In fact, this is what it is called in SQL, which is what I use for databases and what most of the planet uses for databases is SQL. And yeah, this type called datetime combines a date and a time. Very sensible, I know. Great name. It comes from the same people that named the dryer and the toaster. It's exactly what it says on the tin. Other common data types that you might want to use include a date, very similar to a date time, but it doesn't have a time. A boolean and a float. Let's have a look at what these are. So a date, like I said, it's just a date without a time. So if you wanted to store the day someone was born, for example, that would be good. A boolean means true or false, and it's used when there are only two options. For example, if you have a table of users, then there might be a field called isAdministrator that says whether they are an admin user or not, like a special user. There might be a column, a field called isPaidUser. And if it's true, it means that they've paid for the product. And if it's false, it means they're on the free plan. This is a pretty good way to name your Boolean columns, by the way, is underscore and what you're checking. Because normally, a Boolean, it checks if something is there or not, true or false, yes or no. Another one you will see is a float, and a float is short for a floating point number. It just means a decimal value. So an amount of money might be $3.68, or a user's weight, might be 90.17 kilograms. I don't know. So a float is a decimal. The data types that you use obviously depends on the kind of data you need to store. Now, it would be nice if I could show all of the information about the structure of my site, of my database, I should say, without worrying too much about example data here. And for that, we use something else. We're going to use what's called an entity relationship diagram. This is a very, very simple one because there is just one table here, or just one entity. Remember, a table and an entity are practically the same thing, but we'll add some more stuff and make it more interesting. You can see that it shows the same information as before, the name of the table and each of the fields, and for each of the fields it has the type, the data type of that field. I've just shown it in a more compact form here. In each table, you'll often have a primary, well, almost always have a primary key, and the primary key uniquely identifies one of these things. So in this case, if I have a post, I've got a post ID, and that's a number that uniquely refers to that post. If we just go back to the example for a second, you can see that if I used maybe the username to uniquely identify one post, that wouldn't work because I could have two posts from the same user. And I also can't even use the message to uniquely identify one post because maybe two people might both say the same thing. They might both say hello. So in this case, I had to add an extra column called ID to give each post a number. And that way, if I want to, click on a page to focus just on one post, like this one by Violet, I could just look at the post with ID number 2, and that will get that specific row out. Okay, let's go back. So each table has a primary key. We can show the primary key by writing it in bold or underlining it. I'm putting a little icon of a key, but don't worry about that. That's just to help you understand. So how can we show that more than one table might be involved in our database, because it would be a very boring site if there were only posts, but no users and no comments and all those other things. So remember that tables are also called entities. The three entities that we had going way, way back, let's just really, there we go. We had users, posts, and comments were our three tables. So I'll go back again. There we go. Users, posts, and comments were our three tables. We already saw the fields that are involved for a post. The ones that are involved for a comment, also ID, but also you need to know the message that they commented, like what they said as their comment, the user that made the comment, and also the post ID that it applies to. I'll show more about that relationship a little bit later. The users table, you'll need to know their username, you'll need to know their password. In this case, I'm using the username as a primary key rather than adding an ID. You could do it either way. You can add an ID field if you want to, but in this case, I'm just assuming that no two users can have the same username. So that is my primary key. That is the thing that uniquely identifies a user. So each table has a primary key. It's unique for each of them. In this case, no two users will have the same username. One username specifies just one user. And importantly, because this is an entity relationship diagram, it shows how these things are connected together. Because look, a post has a username. And that username, from the table we saw, well, there were only two users, Bob and Violet, right? So that username has to come from the users table. So we can put an arrow showing that every username that is set for a post has to come from this field here. And that will point to a primary key. We can see the same for a username in a comment. Every comment, the username has to come from the users table. And it has to come from this field in the users table. And finally, there is another one here that every post ID needs to match an ID in the posts table. And that is what I want to explore in a bit more detail. These two tables here, comments and posts, they are linked. The post ID here has to match an ID in the posts table. This, hopefully, the end product will match something like this. I will have a post. The post has a message here, which is hello everyone. It has a username, it has a picture, likes, date created, all that stuff. But each post could have multiple comments. So that's what I want to be able to store in the database and show on my site. But how would I store that? This posts table, I already showed you earlier what that looks like in the database. And the comments table here, I'll show you it looks like this one. Pretty similar, I guess. But if I have this post here, I want to show this post in the screen. I want to make a product like this using, for example, Python with Flask. How do we display this list of comments for this post? I've got a post here. It's post number 1. The message is hello everyone. It's by Violet. In code, how would I list all of these comments? Well, what you would do is you would go into the comments table and you would find all of the posts that have a post ID of 1. So this post ID, this column here, refers to the post that it applies to. This hello Violet, you are great, applies to post number 1. And so does this thanks Bob comment, also applies to post number 1. Both of these are for this post. We also have another comment, which we can't see here, called I agree. And that comment applies to post number 3, which is this one, I am Bob. So there would be another post somewhere saying I am Bob and a comment on it by Violet that says I agree. So that's how a relationship works between two tables, where this one here links into that one, and every post ID has to match an ID in the posts table. All right, I hope this has been helpful. If you have any questions, just let me know. And yeah, until next time, enjoy designing some awesome web applications. And I look forward to seeing you on the cover of Fortune magazine. Until next time.